Good evening, everyone, and welcome. My name is Matt McKinnon, and I'm the manager of events at Kitchener Public Library, and I am pleased to welcome you to tonight's event. Before we begin, I would like to start with a land acknowledgement. As we gather, we are reminded that the library is situated on land that is the traditional home of the Haudenosaunee, Anishinaabe, and Neutral people. We recognize and deeply appreciate their historic connection to this place. We also recognize the contributions Indigenous peoples have made in shaping and strengthening this community. We are grateful for the opportunity to meet here and reaffirm our collective commitment to make the promise and the challenge of truth and reconciliation real in our community. So this is our first event of the fall season, and I want to thank each of you and welcome you back to our 85 Queen author events. September 20th to 26th is also Science Literacy Week, and perfect timing for tonight's talk. I also want to thank the Institute for Quantum Computing for approaching the library about tonight's book launch. For more science-related programming, I invite you to visit our website for details, kpl.org. At this time, I would like to introduce and then invite John Donahue to the screen, who will introduce tonight's 85 Queen special guests. John is the Senior Manager of Scientific Outreach at the Institute for Quantum Computing, a research institute at the University of Waterloo. John develops educational materials and events for educators and students of all ages to learn about quantum mechanics and quantum information. He earned his PhD in physics from the University of Waterloo in 2016 with a research specialty in quantum photonics, quantum information, and laser technologies. Welcome, John, and good luck tonight with the talk.
Thank you so much for the kind introduction, Matt. It is my pleasure to be here to discuss this very handsome book, Where Did the Universe Come From?, with its authors, Professors Chris Ferry and Geraint Lewis. Now, Where Did the Universe Come From explores some of the biggest questions in all of science, starting from the birth of the universe and the origin of matter, and taking us to the near unimaginably far future where our stars go dark. Ferry and Lewis show us step by step how the universe was formed, drawing on evidence from cosmological observations and the theory of quantum mechanics. By showing us how effects at the smallest possible scale are responsible for the Earth and the heavens, this book provides a new appreciation for and a fascinating history of both the quantum and the cosmos. Tonight, we are joined by both authors of this book, Professors Chris Ferry and Geraint Lewis, joining us from Sydney, Australia, who I'd like to invite up at this moment. Professor Chris Ferry is an associate professor at the University of Technology, Sydney, and the Center for Quantum Software and Information, where he studies quantum learning and quantum control. He obtained his PhD in applied mathematics from the University of Waterloo in 2012 for work done at the Institute for Quantum Computing. In addition to being a highly influential researcher and educator, Chris is a prolific author of children's books, including the Baby University series that makes topics like quantum physics and quantum computing accessible for even the youngest children. Professor Geraint Lewis is a professor of astrophysics, originally from Old South Wales and now at the University of Sydney's Sydney Institute for Astronomy. His research is in the fields of cosmology, gravitational lensing, and galactic cannibalism, and his stated research goal is to unravel the dark side of the universe. Geraint has previously authored A Fortunate Universe, Life in a Finely Tuned Cosmos, and The Cosmic Revolutionary's Handbook, or How to Beat the Big Bang, both in collaboration with Dr. Luke Barnes. Along with Dr. Barnes, he also co-hosts the YouTube series Alas, Lewis and Barnes. Recently, Geraint was awarded the David Allen Prize of the Astronomical Society of Australia for exceptional achievement in astronomy communication. Chris and Geraint, good morning to both of you, and thank you so much for joining us this evening.
Yeah, thanks. Thanks for the invite.
No. So the subtitle of your book is Our Universe from the Quantum to the Cosmos. Those are two topics we normally think about as fairly distinct. What interests both of you about the connections between quantum mechanics and cosmology? Maybe I'll start by throwing it to Chris.
Sure, thanks. Yeah, so I think the most significant thing that we've learned through combining quantum mechanics and cosmology is that the rules of physics really are the same throughout the universe. So what happens here in our solar system the chemical reactions, the chemistry and physics that happens inside of our star is the same as that in distant stars. And before this, we thought that the heavens were some different place. But now through quantum physics and its connection to astronomy and cosmology, we really get to understand that the physics is the same throughout the universe.
Garrett, do you have anything to add to that?
Yes. So, I mean, I'm a cosmologist by trade, but I remember going through my undergraduate education where you'd be taught quantum mechanics over here, and you'd be taught general relativity over here, and never the twain should meet. And then when you start to do research in understanding the universe, you realize that you've got to get these two theories, which were taught to us as almost separate entities, and you've got to make them work together. And sometimes we know how to do that, and we're pretty confident that we got it right. But as we note in the book, there's plenty of places where we just don't know how to make these two theories work together. So yeah, I love both aspects, and I just wish I knew how to solve this question of how we understand all of the universe by making these two theories work together.
Oh, so as you mentioned, these are two usually things that we encounter separately. All the way from quarks and atoms to black holes and neutron stars is a big span to fit in 200 pages, even 2,000 pages wouldn't be enough to cover it all. What do you hope that readers walk away from this book understanding? What would be your hopeful take-home message? I'll throw it to Grant first.
I think the message that I would like to get across is that, where we think we understand the universe, we understand it very well. So, when we put quantum mechanics and gravity together, which is what relativity really is, as Chris mentioned, that we understand how stars work, right? Stars, there's lots of physical processes going on. That is something that we understand. And across the span of the universe, there's lots of stuff where we've been able to make these theories work. But like all good science, we're not done, right? There are mysteries of the universe still to be solved. So appreciation of how well we've done, but also a realization that we still have a lot to do before we can say, right, that's the universe done for us.
Is there ever a done for us time?
No, because they would stop paying us, right? So
yes.
we have to keep finding new problems.
What about you, Chris? What was your, when you sat down to start writing this book with Garrett, what was your hopeful take-home message that you wanted to tell everyone?
Yeah, so to be honest, I'm a little bit jealous of Grant as a cosmologist. You can see behind me, I didn't put up a picture of a quantum physics lab. I put up a picture of from NASA, right? So I find that it's difficult as a quantum physicist to connect with people in the same way that you can easily connect with them by sharing this view of the cosmos. And so throughout the book, I really wanted to emphasize the importance of quantum physics in our understanding of the cosmos, and do it in a way that's different than is usually done. So you say, well, we look out and we see all these little points of light, and they're just they're other suns like our own, and we know that because quantum physics. Quantum physics is weird, so just take my word for it. I wanted to avoid that sort of typical story and really help people understand what parts of quantum physics are important and how you can really make that connection for yourself.
All right. So in this book, you do talk about a lot of terms that people who follow the science news might be vaguely familiar with, things like the Big Bang, quantum entanglement, quantum tunneling, black holes. But there are a lot of things that are in the book that people might not have heard of at all before. While you do spend the time, of course, needed, you don't need to be an expert in quantum entanglement or black holes to read this book. But what are some of the topics you explore in this book that you don't think get enough attention in the popular science media? I'll throw it to Chris first.
Sure. Yeah, so I think, as I kind of alluded to, the typical way we approach scientific communication is through listing facts, right? The universe is 14 billion years old. It's 95% dark matter and dark energy. the temperature of the universe is 2.7 degrees Kelvin. So we like throwing out these facts, and facts are important, but it gives this false impression that that's what science is. Science is just the list of facts, right? And I guess during Scientific Literacy Week, and now it's a good time to say that's not what science is, right? Science is a collection of stories about those facts. So certainly we need the facts, but that's not the purpose of science, is not to compile these facts. So the thing that I wanted to do for my part as the expert in quantum physics in the book is really talk about an understanding of these concepts that are essential in the description or the explanation of these cosmological phenomenon. So going through things like entanglement and explaining what is that in its own right, not necessarily connected to something in cosmology. So let's discuss that and let's get an understanding of that. And then we can make the connection for ourselves to the cosmological observations and facts.
Okay. Garen, was there anything that you really wanted to make sure was included here that you thought needed a spotlight?
There's a couple of things, of course. I very much agree with Chris that the question of the scientific journey, right? It's not a series of facts, it's asking questions, but also getting across that notion that there's a lot of stuff we don't know. And a lot of popular science can seem, very much like, here are the words from on high by the priestly scientists. But of course, the most important phrase in science is, I don't know, I don't understand that yet. And so getting across the fact that there's still stuff for us to do, the mysteries to solve, I think is an important one in my viewpoint, especially to encourage younger people into science. The last thing I would want somebody to do is think that, as I said, that the universe is done and there's nothing left to be written. There is so much more that we need smart minds working on if we're ever going to crack the question of, where did the universe come from?
So I find that to be a really interesting way to approach it. I do appreciate what you're saying, that a lot of the stuff you do read is just lists of facts about science as opposed to trying to tell a story about the science. Of course, in both of your day jobs, you spend a lot of time teaching that at the university level, I imagine with a lot more mathematics, although maybe similar diagrams as to some of the illustrations that made it into the book. Has the process of writing a book like this informed how you teach at that senior university or graduate level? I'll throw it to Grant first.
Yes, I mean it's two ways. I mean I've always tried to teach by using analogies and pictures as well as the mathematics. So currently I'm teaching general relativity and cosmology to our fourth year honors class. And I remember my general relativity class, which was essentially, the material was thrown at you, equations flying at you. And very rarely was there an opportunity to stop and think what the equations mean and what they were telling us. So I have tried to bring that into my teaching, but also to inform the writing. So I try and balance between the two. So yeah, I think it's important. I think that, again, there's an aspect of science that does get lost in that this notion of, like, physics, of course, is highly mathematical, but a lot of it is understanding what the maths is telling us. And for that, we need to stop and think and have pictures in our mind.
Chris, do you have anything to add?
Yeah, so I, as at least for one project in every class, I actually have the students write a story. I can't have them write 50,000 words, but so I have them write a kid's book. And I think that process of storytelling is important for your own learning. One of the selfish reasons for which I write books is because that process of telling your story really helps you understand the concepts yourself. Right? So the famous thing for becoming a surgeon, right, is learn one, do one, teach one. So you can't become a surgeon until you've taught somebody else how to do surgery, right? And I think we should really adopt that point of view in all areas of advanced knowledge. That to teach it really is the ultimate proof that you have a mastery of the topic.
Speaking of mastery of a topic, I think when a lot of people think of a physicist, they sometimes think of someone who sits in an office and just has knowledge about absolutely everything. Of course, that's not how it works. You get to your PhD, you start focusing on something, and then you really kind of laser focus in on that, and the rest of the world often seems to be walled off for at least a while. Both of your research interests are on basically opposite ends of the quantum to cosmos continuum, with Chris, your focus being more on quantum information and Garance being in cosmology and astrophysics. So what's the story behind how this book came together? What inspired you to work on this collaboratively? And I'll throw it to Chris first.
Yeah, that's right. We, had we not written the book together, even if we were in the same university, although we're only a 15-minute walk away from each other when we're allowed to go to the university, we probably would never see each other. Maybe the occasional faculty meeting, maybe. We were both theorists, so we both work at the chalkboard, but Garant visits his experimental colleagues and I visit mine. I go to the basement, he goes to the roof. So we go to different places. We teach separate subjects. It's very much separated. And you even though you specialize, you get a general knowledge going through taking your subjects. And so I knew the connection between quantum mechanics and cosmology, but I didn't know it deeply from the cosmological side. I don't know the details, right? I can tell the general story and the brief picture, but those specialized details, that's Garant's area of specialty. So that's, I think, why it worked great for us to come together, right, and meet at the middle and really kind of explore what hasn't been explored in this space of telling the story of the connection between quantum mechanics and cosmology.
How about you, Garant? When this idea came, I guess I'm not sure how this idea, like who approached who in this circumstance. When it came to you, what was your thoughts?
Well, if I remember rightly, it was Chris approached me about an idea behind putting a book together on this topic, and I mean, I find it very exciting because, of course, as you mentioned, as we become researchers, we do tend to become very blinkered, and we don't really follow in detail what our colleagues are doing, but we hear the buzz around it, right? And there's a lot of buzz around, quantum computers are on the horizon, etc. And I feel as a physicist, I should at least have more than a pop sci knowledge of what's going on in other fields, and I try to expand my knowledge, and talking with somebody in the area can greatly advance your knowledge and also get the concepts straight and see through the hype, right? You read a headline about quantum computer is going to be here tomorrow kind of thing. You do need to sit down with somebody who knows the field for them to say, right, it might not be tomorrow, but it might be this time period, etc. So for me, I actually enjoy that opportunity to talk to other scientists about their science, and not only in physics. I actually, as I've gotten older, I've realized there is so much I don't understand about the world. So I've been trying to understand things more broadly, and the way to do that is to talk to people, and this kind of collaboration is one of the things that comes from that.
Garant, I don't know, it popped into my memory where we met. So we met on a local Australian science comedy podcast, and and I think the goal was to get us to battle quantum versus cosmology.
Yeah,
and
right.
throughout the episode, we learned, like, oh wow, we have a lot more in common than we than we thought. Let's write a book about it.
Huh.
Yeah, it's all coming back to me. Yeah, that's what it was. Yep.
If you can remember the name of that podcast, I want to give them a plug by all means.
We know the name. It's Scigasm.
Scigasm. Okay.
Yeah.
Yeah. Keep an eye out for that, everyone. So as you mentioned, this book was a learning process for both of you. A quick glance at the footnotes shows that a great deal of research went into this book. Each reference, I appreciate that it's accompanied by a glowing and specific recommendation as opposed to being like, see page 81 of X. There's actual context there. What was the most surprising thing you learned while researching this book? And I'll throw it back to Geraint first.
Oh, that's a good question. I mean, for me, of course, the cosmological story is in my mind, and I've worked on, aspects of nuclear physics in the early universe when the first atoms formed. That's an area of my research that I've looked at. But for me, of course, it was to try and understand the modern viewpoint of quantum mechanics, right? So I did my undergraduate in quantum mechanics now almost 30 years ago, and things have advanced. And again, I have a sort of pop-sci view of what modern quantum mechanics involves. So having a chance to go deeper and try and understand, firstly, where we're at with quantum mechanics, and secondly, where the field hasn't moved along, and it's the philosophical battleground, right? Quantum mechanics is one of those areas that people do fight about in terms of philosophy. And so just picking apart where the field sits. So for me, it was getting out of my comfort zone, which is the cosmological, and trying to understand what modern quantum physics is telling us. And I definitely I'm going to admit right now that I do not understand it all, but I definitely have a better viewpoint than I did.
All right. Chris, how about you? What were some of the surprising things that you learned researching this book?
Yeah, I think it's a similar story to what Grant said. So, I had this pop sci knowledge of how we explain cosmological observations, but these subtleties in each sort of section of the book, we talk about some cosmological phenomena and then how quantum mechanics sort of helps explain that phenomena. And a lot of times I thought that was the end of the story. We that was it. We knew it. And then Geraint comes back and says, actually, that's probably wrong, And the latest research is suggests that that's definitely not right. So it's the best thing we got going on for us at the moment, but it's going to change, guaranteed. Well, one funny thing that I learned is in Waterloo, in addition to the Institute for Quantum Computing, there's also the Perimeter Institute, where a lot of foundational physics is researched and discussed. And as a PhD student, I would hang out there sometimes and learn about the foundations of quantum mechanics. And one of the things that we discussed a lot was the many worlds interpretation of quantum mechanics. And then you hear like Neil deGrasse Tyson in his very good TV shows and in his own sort of media, he talks about the multiverse. And I always just thought these were the same thing. I just thought, I knew what the many worlds interpretation was, and I just thought the multiverse was just, some additional, creative license put on top of the many worlds interpretation. But Grant taught me that that's not the case. It's different. It's different than the many worlds interpretations. That was one like fun, specific thing that I remember learning from writing this book.
I'm gonna have to check my word choices in the future based on that. So many worlds theory is actually a great example of a theorem that is out there that is consistent with what we know, but is hard to find a definite answer to. Is this the correct interpretation? Near the end of the book, you talk about theories of everything and other kind of unanswered questions in physics. From a distance, these problems seem pretty insurmountable. And we know a lot about the universe already. How can we possibly learn more? But are there some of these unanswered questions that you're actually optimistic about scientists finding answers to? What are some of the spaces that you're keeping an eye on? I'll throw it back to Geraint first.
Yes. For me, the title of the book, right? Where did the universe come from? Okay, so as a cosmologist, I know how much we understand about the universe, but as we push backwards and backwards to that initial point, right? This point of the universal birth, whatever that means. Now, I know that there are some pop sci books that they say, like a universe from nothing that is guaranteed that before our universe there was nothing, kind of thing. That to me is a huge mystery, right? We do not know where the universe came from, not to spoil the book, of course, and we don't know what kind of structure was there before our universe was born, or and how we're related to that structure, etc. But it seems to me that that is one of the things that will be answered once we know how to make quantum mechanics and gravity work together in a way that doesn't have the problems that we currently do. And as you mentioned, there are theories of everything on the table that might be the solution. And once it's cracked, I think we will suddenly say to ourselves, right, our universe before 14 billion years was like this, and we will understand that. Now, I am very optimistic that that is something that we will solve. Now, the problem in my mind is the timescale of solving it, right? I want it to be solved tomorrow, and it could be, right? We just need a smart person to suddenly go, hang on, and then go, right, we've got it. But I think we've become sort of complacent with the rate of scientific progress, and we just want it to be done tomorrow. But I wouldn't be surprised if it's another 200 or 500,000 years until it's solved. We can't expect that our solutions will be there tomorrow. But what keeps me happy is the prospect that it could be solved tomorrow. So that's where I'm at.
There's the hope.
The hope, that's right.
Chris, where's your optimism lie?
Yeah, so there's a nice quote, I think it's from John Wheeler. He says that like our scientific knowledge is like an island in this like vast, probably infinite sea of ignorance. And as we grow our island, we also grow like the shore of ignorance, right? So as we learn more and more, we just open up more and more questions, right? So the more we learn that we don't actually know. And somewhere sitting out there in the ocean, there are these big questions. And I think, we'll grow our knowledge to the point where we answer them. I don't think the really, really big questions will be answered in my lifetime. I'm optimistic that they will be answered. But if I think about what's the biggest question, I think, in science that will be answered in my lifetime, and it's kind of like the one that I'm kind of most interested in, maybe because I think it could actually be answered, is how did life arise on Earth? I think that's a big question that requires knowledge from all branches of science, and we're getting ever closer in each of these branches to coming up with a real provable answer to that question. How did life arise?
So I think now is actually a good time to work in a couple from the Q&A. Note that the Q&A is going to be open for a little while longer. So if you have any questions you want to ask, please feel free to throw them in there. The first one is squarely aimed at Chris. So it's from James Nickel. When it comes to quantum mechanics, I've always been fascinated by the idea that things at that scale seem to act differently if they are being observed. Could you give a bit of an explanation as to what that might mean?
Yeah, sure. I can give it a go. So the way I like to think about quantum physics is it's a theory that describes things that are isolated in an information sense. So if you have something that doesn't leak out any information to its environment, then you're going to need quantum mechanics to describe how that thing acts. And well, once you go to investigate it, then by necessity, information has leaked out. It's gone from the thing to you anyway, if you're going to learn something from it. And so that means that the rules of the game have to change. It's no longer described by quantum mechanics, because quantum mechanics describe the thing in isolation. So that's why when we look, the rules are different. We have these separate rules for when things are being looked at and when they're not. And it's all about, is information being leaked out of that system?
And we have another question from Yasser. I'll throw this one to Garant first. We talked a bit about theories of everything. You talk about that a bit in the book as well. One question from Yasser is string theory a contender? Is it mature to explain the universe?
Oh, I'll give you a personal story about string theory if you want. I started my undergraduate degree in 1987 at Queen Mary in Westfield at the University of London, where there was a physicist there, Michael Green, who's considered one of the, maybe he must be a grandfather of string theory by now rather than just a father, right? He's been around for quite a while. And I remember being told in 1987 that any minute now, string theory is going to crack it, and we're going to have a theory of everything, and the universe is going to be solved. And here we are now in 2021, and things have advanced, but I still haven't seen this this solution to everything, that string theory, which has morphed into this thing called M theory, that it is a viable working theory of everything. It has many supporters, many people working on it. But if you wanted to use it to calculate something that physicists might want to know, like, where did the universe come from? It's still full of ambiguities and approximations. It's not a single solid mathematical framework. So yeah, this is why even though I've been told the solution is just around the corner many times, that corner tends to be a big corner in the end. So, and in fact, Michael Green might actually retired by now, I think, if I remember rightly. Yeah. So yes, you can work on these things for a long time. Doesn't guarantee that it's going to be a success, but it's a contender, right? I mean, what's the movie from? I Could Have Been a Contender. I can't remember the movie, but you know what it is. That's it's a slugfest between the string theory and alternative possible theories of everything, or we could just be on the wrong road with all of them.
Mm-hmm. I think that was On the Waterfront. I think it's on.
Okay.
Okay, I've kind of threw both of you a science communication question because both of you have dedicated a lot of your career to science communication. A book like Where Did the Universe Come From? I could imagine a 15-year-old version of me just eating this up. This was the kind of thing I ate for breakfast when I was thinking about what I would get into, what I was going to study. And I have to imagine that you had books like that and shows like that and different things like that when you were that age as well. So what books, other kind of media about science inspired you when you were deciding to get into this line of research? I'll throw it back to Chris first.
Yeah, to get into research, it was really a professor of mine in undergrad. I think it was in third year. It's a Professor Donna Strickland at the University of Waterloo. She taught me electricity and magnetism, and suggested during one class that I work in her lab as an undergraduate research student over the summer, and I did that, and that was my first taste of research. And I think until then, I was really naive about it. I thought everything was known, and that's why I was at university, just to learn everything that was known. I didn't realize that in fact, we basically know nothing and we'll know even less and less over time. So that was sort of the thing that pushed me into research. Although I had always had an interest in science. I spent, as a 15-year-old, as a teenager, reading more popular science magazines. But I read Stephen Hawking and Brian Greene, and so I had some fascination for theoretical physics. Of course, my first start was in an experimental physics lab. I think serendipitously, the laser was broken, and so I had to actually study the theory. And then that's what eventually pushed me into theory. Yeah.
Laser is always broken. The laser is always broken. All right, Geraint, what about yourself? What books or other experiences inspired you when you were deciding to get into research?
Okay, hard to remember. I mean, I used to read science, New Scientist, and I'm thinking of the books that I used to read. When I was very young, I had a lot of how, where, what, and why books, right? They covered a lot of topics. I was very into dinosaurs, like young people were. But this is going to sound kind of weird, right? What got me into science proper was the world of the mysterious. So Arthur C. Clarke's Mysterious World, The Unexplained, all this, almost paranormal kind of stuff. I read a lot of that when I was younger because I guess at some level I didn't know that a lot of it was bunkum more than anything. But there were questions being asked, and I mean, I started university in '87, and it was the early '80s that there was a buzz in particle physics because people had basically cracked the weak force. So I heard about physics, etc., through that route, and I'm not 100% sure what I was reading, but I did read books on. There was a flurry of books on quarks and forces going on in the very small scale universe. And I actually started university, wanted to focus more on particle physics, but I still had this interest in the universe at large. I would read astronomy magazines. I didn't have a telescope when I was younger. I grew up in South Wales where it's always cloudy, so there was no point having a telescope. But I read about the universe and the articles about how the universe behaved. And so I had the astronomy as a sort of side thing during my degree with this idea that I would focus on particle physics. But I was drawn into the questions of the universe at large. So it evolved from wanting to understand the world of the very small that led me into finally saying, right, it's actually understanding the universe. That's where I want to be. But Arthur C. Clarke's Mysterious World was a good starting point.
Good to know. Good to know. A bit more recently, have there been any books that you've been reading that you'd recommend to people who enjoy Where Did the Universe Come From? I'll start with Grant.
Yeah, look, I read a lot of books across a lot of topics. As I mentioned, I feel like there's a lot of the universe I don't understand, especially the human universe. So I've been reading about economics and history and things like that. In terms of physics, there was one recently that I did enjoy, which was Paul Steinhardt's The Second Kind of Impossible. So I know Paul Steinhardt through his work in cosmology, right? So he worked with Neil Turok on a cosmological model that says that the universe cycles and all this kind of stuff. And I didn't realize that he had another line of research, which is these things called quasi-crystals. So these are crystals that don't have simple repeating periodic structure. So he developed this entire theory about that. But the book is a personal journey about him trying to find them in nature. So it's one of those ones that nicely discusses the physics. Again, very maths-like, explaining what these quasi-crystals are, but written in there as well as this journey of him to Kamchatka in Siberia to search for natural quasi-crystals. So it was an interesting read because, again, sometimes the story of science leaves out the scientists as people, right? They're names, but they're not people. But this made you feel like you understood Steinhardt's journey to try and find, proof of his theoretical ideas.
Fascinating. Anyone interested in that? The link for that is now posted in the chat. Chris, what about yourself? Any books that you've been reading recently that you'd recommend to fans of yours?
Yeah, I mean, not recently, but Grant's other books are great, so I'll plug those for him.
And Chris's books are great too. So
no, I recently read two that were on the topics separately, so quantum and cosmology. So the one in cosmology was Katie Mack's The End of Everything, which we touch on a little bit in our book, but Katie goes into gory detail about all the possible ways the universe could end, and it's a great read. She's got her kind of unique style, and there's a bit of comedy in there as well. And then the best quantum physics book I've read recently, I think it's a couple of years old now, but it's it really was great. It was Philip Ball's Beyond Weird. And I approached it with skepticism because like, oh no, here's another book saying quantum physics is weirder than weird. But no, the point is, let's get beyond the notion that it's weird. So I don't know if he meant to have that sort of ambiguous title, but it's a very sort of down to earth, no nonsense take on quantum physics. So those are my two recommendations.
Very cool. So books like these, as we've kind of mentioned, are, interesting for everyone, but really key for young students figuring their way out in university, maybe getting into research. What would be your advice to young students who want to get involved in research in your field? Starting with Chris, while I have you.
Sure. Yeah. So I think I mentioned earlier that I see science as a collection of stories, and to write good stories, you need to know the techniques and certainly the language in which you're going to write it in. And science is a collection of stories written in the language of mathematics, and so you have to be well versed in mathematics, and not necessarily like the training that you get, no matter where you are in the world. It's always a little bit different depending on where you are. It seems quite divorced from, well, anything. That's why students always say, when am I ever going to use this? But it is training, right? And at some point it's not obvious when you reach that point, but at some point you look back and you say, somewhere something changed, and I have this new way of thinking. This sort of, you reach this level of mathematical maturity where it's not about adding things, it's not about arithmetic and being able to multiply numbers or being able to find the factors of large numbers really fast or anything like that. It's just a way of creating abstract models and reasoning logically about the world. And you really need to have that strong foundation. And it's not just useful for science, it's useful for everything. So whenever I meet a young person, I guess they're focused on their schooling or whatever. So I make sure to say, do your math homework first of all, but also do more, right? The more practice you have, the better you'll get at it.
Excellent. Grant?
Yeah, this is a question I've thought about a lot. I actually think that a lot of our physics degrees are not very good for actually training people to understand the journey of research, right? I mean, the act of doing an assignment is very different to the act of approaching a question that nobody knows the answer to. I mean, when you do an assignment, you assume that your lecturer knows the answer to that assignment. They can say yes or no. And so this notion of changing your mindset, that it's not all about I need to get 75% in this, but it's I need to find an answer that nobody knows, I think it requires a very particular shift in the way that your mind approaches problems. And we do have research training for undergraduates, etc., at various universities. You get them involved in research projects, and it's always nice when you break that view that is held at, this is almost like an assignment, I just need to answer it, to when they suddenly realize, oh, this is interesting and nobody knows the answer, and in fact nobody's quite sure what the question is, and they start to define their own directions where they want to find particular answers. So yeah, it's, if somebody is interested in going down this road of becoming a research scientist, I think their undergraduate degree has to have those additional kind of research opportunities and projects that students can get involved with, just so they can realize what research really is. As Chris mentioned at the start, it's not about collecting facts, it's about answering questions, and answering questions is a journey, right?
Oh, absolutely. Absolutely. Well, thank you both so much. We're going to move into the Q&A now. So we have one question from Kaylee. What was one of the most fun experiences you had writing this book together? Whoever wants to take it can take it.
I'll let Chris start. I'm trying to think. I mean, we didn't sit down together at one keyboard and when you see pianists playing the single keyboard together. We wrote this back and forth, so we weren't usually in the same room. So but for myself, just the discussions, right? I mean, we had to decide how we would structure the chapters, right? And so we have this chronological for the universe, But in each chapter, we have a section, and each section, what we wanted to do was pose a problem for the universe, and where I could talk about how the universe, gravity does this kind of thing, but then Chris would come in the middle, and it would be, you know, but you need to consider this aspect of quantum mechanics, and then we would round out the chapter by, you know, showing how they work together. That kind of thought process of how we structure everything was fun, right? I mean, it's one of those things. As we didn't set out to list a collection of facts. We wanted to lay out a journey and sections of journeys. So for me, that was a fun aspect.
Yeah, it was very much like research in the sense that you know, a lot of the discussions that we had got thrown out. Probably don't remember, you know, remember the proposals and ways we were going to do it. You know, there was many false starts, like in research. And I guess this is an example from what I said before about how, you know, having this sort of mathematical, you know, mindset, this way of thinking. You know, once we decided on the structure in the formula, then it was almost like, okay, now we can get going, and now we can turn the crank, and things can move along quickly. But all the hard work and discussion was coming up with what that formula was going to be. And that's sometimes the most exciting part. I can tell you one of my son's favorite parts of the book writing process was when we were going to meet at my office, but there was a fire alarm, so we had to go across the street to the mall, and we had our meeting in the food court, and I don't remember why. My son happened to be at work with me that day. But I think it must have been over school holiday. And there was an arcade there. And so I think I loaded like $50 or $100 onto the card for the arcade thing. And yeah, and then he came back 20 minutes later and was like, I spent it all.
That's impressive.
So there was some fun times, certainly in the process. But you know, a lot of it was you know, we wrote it during the pandemic, so I had to be sort of virtual and asynchronous.
Mm-hmm. And then we have one more question from Leo, who was not going to let us go with a hanging comma. So I'm going to throw this one to Durant for starts. What's the difference between the multiverse and many worlds?
Well, that's a good question. Many worlds is one of the possible multiverses, right? So many worlds is this idea, of course, that you create separate universes every time a quantum decision is made, etc. But there are other multiverse theories. So there are, and I'm going to use air quotes for theories because these are more speculative ideas than robust mathematics. But there are multiverse ideas even within M theory, right? That our universe is a distinct universes from other universes which are floating around that are not created by this quantum mechanical process. That there's a universe generating something somewhere hidden in the n dimensions of whatever reality is, and that our universe is just one of a multitude of universes. So multiverse has a bunch of different ideas of what multiple universes could be, of which many worlds is one of them. I mean, if the person's interested, that they should look up Max Tegmark had a Scientific American article on he categorizes multiverses into different levels. So he talks about, even in our universe, if it's infinitely large, there are chunks out there which we will never have contact with, where the laws of physics might be different to the laws of physics here. So that is a level 1 multiverse, right? There's different universes within our universe. And then a level 2 is that you've got that, but then there are distinct universes which are completely separate structures to our universe. And then you can just work your way through these different levels. So yeah, multiverse is a catch-all phrase, of which many worlds is just one of the contenders.
All right. Okay, hopefully that clears it up. Chris and Grant, thank you so much for joining us tonight. This has been a pleasure. I think we're running out of time. Where can people find more information about you, your research, and your other science communication works? Starting with Grant.
So I'm on Twitter at cosmic_horizons, where I spend a lot of time fighting with people who propose theories of everything that don't work. I have my own website where I try to blog occasionally. So that's gerantflewis.com. And I have a YouTube channel, Alas, Lewis and Barnes, where I sit down with my colleague, Luke Barnes, and we talk about questions to do with cosmology and physics, etc. So there's a whole bunch of them there, from Birth of the Universe to the way stars work, to the 2 books that we wrote previously together on multiverses and fine-tuning, and also how you should approach overthrowing the Big Bang if you've got a theory of everything.
Very cool. All right. I think there are some links in the chat as well. Chris, what about yourself? Where can people find more about you?
Yeah, I think probably the best place is my personal website, csferry at csferry.com, and also on Twitter. Please don't send me your theories of everything. Proposals. Yeah, so it's a same handle, csferry. Yeah.
All right. Well, thank you once again for joining us. Have a great late morning coffee. I'd like to, and thank you to everyone else for joining us and for the wonderful questions in the Q&A. I'd like to invite Matt McKinnon from the Kitchener Public Library back to close the event.
Hi, I'm here. No, thank you, gentlemen. That was a great discussion. Chris, I just sent you a bunch of messages on Twitter for my own theories. I apologize. It caught me too late. My bad, but I think they're pretty solid. No, thank you for choosing. Thank you to the viewers out there for choosing to spend your evening with us, and for your questions. Geraint, we have some Welsh weather happening here tonight. So lots of rain in the forecast and lots of clouds for the next like 72 hours. So people who are wanting to rush outside with their telescopes now, apologies. That's not going to happen. We didn't time this right. It's the Welshman. He brought weather. So as is always the case. But I also want to note that one lucky viewer will receive a copy of Where Did the Universe Come From? Well, we were doing a random draw, and we'll contact you tomorrow, the winner. And you can also access the book with your library card, because we are a library after all, and you can check it out. I think there are some holds on it already. So, and also we have Chris's books for children on science here. We have in our children's collection. I would strongly encourage you to check them out. They're a great read for youngsters and that, and a good sort of stepping stone into science. And both of you, some of the takeaways here is Chris, like, science is a collection of stories about facts, and Geraint saying, answering questions is a journey. I think, those are important points to be underlined, where, the whole question of I don't know comes up, where it's a starting point in science, and like many things in life, there's not somebody with all the answers in that, and part of your roles and what you do and your research is trying to answer those questions in that. So, and it is a journey, and yeah, and I don't know, I'm really good at not knowing anything, so it's really helpful to hear that. So just on a personal note, yeah, just to highlight upcoming events for us that we have coming. We'd like to share details about another upcoming science talk. This is October 13th. It's a conversation with Dr. Sarah Birch from the University of Waterloo here, and Dr. Catherine Hayhoe on a recently published book, Saving Us. Dr. Hayhoe is a climate scientist, so she has a lot to say on this very, very timely topic, and registration details can be found on our website. I would also like to thank Wordsworth Books for their ongoing support of our author events, and copies of Where Did the Universe Come From are in stock, and they are kindly offering a 10% discount if you mention that you attended this event. And as with all our 85 Queen events, we will be posting this talk on our YouTube channel, and we invite you to share it. And with that note, I want to thank both of you, Chris and Geraint, and also John, for doing a great job moderating tonight. And yeah, thank you, and take care and keep on learning.